It's good to come your way once again. In our previous lesson, we have looked at how we can draw a graph of a parabolic function with a linear function, where we have looked at being able to find the solutions to these two functions when they are drawn together. My name is Nana Yawedu, and you can call me Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell in order to get all videos on time. In this lesson, we want to look at yet another example on the parabolic function, and we want to consider how we can draw that parabolic function. We are looking at several examples because it's important that you know how you can draw the parabolic functions so that you can interpret the graphs around these parabolic functions. So let's consider that question. So in this question, it says that plot the graph of, right? So we have y is equal to 2x squared minus x plus 2. 2x squared minus x plus 2 for the interval. So with this question, you'll be given an interval which is minus 2 is less than or equal to x is less than or equal to 4. Right, so let's look at how we can solve this question. So the graph or the function given is y is equal to 2x squared minus x plus 2. And we are doing this on the interval of minus 2 is less than or equal to x is less than or equal to 4. So we are going to have a table, right? So we'll draw a table for this graph. And in this case, we are going to use a calculator to do it straight away without necessarily putting the values in here to be able to solve. So look at how we can go through punching the values and getting our values for our y. Right, so we have our table. So we have, right? So in the table, we'll look at our x values. So for our x values, we have values from -2, we have -1, we have 0, we have 1, we have 2, we have 3, and then we have 4, right? And then we want to find our y, solely one graph. So in this case, if x is equal to, right, -2, that means that we can have 2 multiplying -2 all squared, right, minus 2, right, or minus 2, because in this case it's -2, right? So minus 2. So you can use a calculator to punch this, and then you get the value, right? So plus 2, and that gives us 12. So it means that the y value for -2 corresponds to 12. And then we only change the values in the bracket. So in this case, the next one will be -1. So we are going to have x to be equal to -1, right? -1. And then all squared minus -1 plus 2. In that case, we are going to have 5. And then when x is equal to 0, we are going to have 2, because all the values of x here become 0. Then when x is equal to 1, right, it means that in that case, you are going to have the value of y to be 3, right? When x is equal to 2, then we are going to have the value of y in that case to be equal to, right, 8, right? And then when x is equal to 3, we are going to have the value of y to be equal to, right? So when x is 3, the value of y is equal to 17. And then finally, when x is 4, the value of y is going to be 30. So when x is 4, the value of y will be 30. So we've gotten all our y values. So in this case, we want to plot the graph of this function, right? So we want to pick a graph so that we plot the graph of this function. So we are going to assume values for x and y, right? And remember that we want to look at the highest value of y to determine the scale. So since the highest value of y is 30, then it means that we could be able to use values between 5 and 10 and 15 as a scale for the y values. So let's draw or plot or draw our graph here. So it means that in the graph, we have our x-axis, right, which should be here, Now let's use this. And then we'll have our y-axis. Right, so most of the points on the y-axis are positive. So we must actually ensure that we have more values on the y-axis than the x, right? So this line is deviating. Let me clean it. Right, so we are going to have our point, right? So our point on the x is -1, -2. Let's add -3 here. And then on the x for the positive side is 1, 2, 3, and 4. So we could add 1 to get 5. And then on the y, we see that we can have 5, we can have 10, we can have 15, we can have 20, we can have 25, then we can have our 30. Right, so we want to plot the points because when we look at the y, all the points are positive. So the first one is -2 and 12, and then we have -1 and 5. Right, so let's plot the points for -2. So -2 on the x-axis, 12 on the y-axis, so that comes somewhere here. So -2 and 12. Right, and then -1 and 5. Right, -1 and 5. So -1 on the x-axis and 5 on the y-axis. So you should as well be trying this one as well on your own. And then we have the next one to be 0 and 2. So 0 goes with 2, so 0, and then 2. Right, and then the next one is 1 and 3. And then this one is 2 and 8. So we have 1 with 3. Right, so we are climbing up. Then we have 2 with 8. We are climbing up. And then we have 3 goes with 17, and then 4 with 30. So 3 goes with 17, right, which is here. Right. And then 4 goes with the last value here, which is 30. So we can draw our curve, right? This one, freehand, to pass through all the points. So this is our quadratic graph. Y is equal to 2x squared minus x, right? And then I think plus 2, right? So plus 2. So plus 2. So I believe that through this series of graphs that we have drawn, you are able to know how we can draw the graph of parabolic functions and then be able to know what it means to find the maximum value and all the other things that are associated with parabolic function. In our next lesson, we want to consider a revision question where we will look at how we can model what we have learned in linear functions and in parabolic functions in solving a question. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.